Hi, Mr. Chu here, and I give you a very warm welcome to my study room. If today is your first time, then as usual, I will encourage you to go back and subscribe to my channel for more videos like this. Today our study is simple. We are proving the quadratic formula using the method of completing of squares. Let's go straight to the lesson. Thank you. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and this is obtained from the general or standard quadratic formula ax squared plus bx plus c equal to 0. Now we are going to use the method of completing of squares to find the solution of this equation here. To get this, just meaning we are going to make x the subject of the general quadratic equation to get the quadratic formula, and we are using the method of completing of squares. The first thing we are going to do is that we have to make the coefficient of this x squared, the first term, to be 1, and that means we have to divide through each term by a. So when we divide through, let me just do that systematically so that everyone will follow through. So this is over a, this is over a, this is over a, this is over a. So when we divide through with the coefficient of x squared, this a will go away with this a. So we are going to have x squared plus b over a x plus c over a equals 0. Right. The next thing we'll do is that we'll let the constant term here go to the right hand side of the equation, and that will give us x squared plus b over a x being equal to, this is positive, so when you go to the right, become negative c over a. Good. After that, this is the coefficient of x now. So we are going to take half the coefficient of x and we add the square of that to both sides of the equation. The easiest way to find half the coefficient of x is to multiply it by 1 over 2. So that is 1 over 2 times b over a. That is the coefficient of x. No common factor. So the 1 times b will give us b. 2 times a will give us 2a. So now we are adding the square of this way to both sides of the equation, and that becomes x squared plus b over ax plus this square b over 2a all squared equal to negative c over a plus b over 2a all squared. After that, we are going to factorize the left hand side and simplify the right hand side. And this is an expansion of a perfect square. So I don't want us to go doing so long thing. In factorizing this, you pick one of each of the squares and square both of them. So this x squared and this is b over 2a squared. To factorize this expression here, we are going to have, we'll pick one of these, which is x. Then we pick one of these, which is plus b over 2a. Then now we square both of them. That is how the factorization is done. Then now we simplify the right hand side. Because this is negative term, I would like to bring it second and bring the positive term first. So I'm expanding this one. I'm opening the parentheses now. So b squared will give me b squared. 2a squared will give me over 4a squared. Then now minus my c over a, because I said I wanted to bring the negative term second. We are still simplifying the right hand side. That means we are going to have x plus b over 2a all squared being equal to, this is subtraction of fractions, therefore we need the LCM. And the LCM of 4a squared and a is 4a squared. 4a squared will go into 4a squared 1 or once. 1 times b squared will still maintain our b squared, or still give us b squared. Then minus this one will go into 4a squared 4a times. So 4a times c will give us 4ac. Alright. Then our aim is to make x the subject of the equation. Because of that, we have to open these parentheses, and that is by taking the square root of both sides. And when we take the square root of both sides, square root of here will get rid of the square. So that is going to give us x plus b over 2a, and that should be equal to plus or minus the square root of the right hand side, and that is b squared minus 4ac all over 4a squared. We continue to simplify the right hand side, but before that we can move this term here to the right hand side so that we can make x the subject. So our x becomes, this one becomes negative b over 2a plus or minus the square root of this is the same as, if you remember our said lessons well, this is the same as the square root of the numerator over the square root of the denominator. So the square root of the numerator will remain square root of b squared minus 4ac. Then the square root, this is a perfect square. This is a perfect square. This is 2a squared. So the square root of 2a squared is 2a. So that gives us 2a now. Good. Then addition and subtraction of fractions or common fractions require us to find the LCM. That means our x is going to be equal to, the LCM is 2a and 2a, so it's 2a. So you write our 2a here. Then 2a will go into 2a once. 1 times negative b will give us negative b. Then 2a will go into 2a once. Let me bring my plus or minus. 1 times everything here will give us square root of b squared minus 4ac. I forgot to bring the c here. 4ac. And that becomes our quadratic formula. This one becomes our quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You can go back, play the video again, and look through the steps with the explanation one by one. So this is the end of the formula, since we just wanted to prove that this expression, the general expression ax squared plus bx plus c equals to 0 will give us x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that is how we prove the quadratic formula using the method of completing of squares. Nice. So that's a proof of the quadratic formula using the method of completing of squares. In our next studies, we are going to use the method of completing of squares to solve quadratic equations that we cannot factorize, or quadratic equations that factorization method cannot be used to solve. So when we get there, we are no more going to prove the quadratic formula, but we are just going to use these steps in the completing of squares one by one to work out numbers to solve the quadratic equations that cannot be factorized or that cannot be easily factorized. So please take note of these steps very well, so that in the next video the understanding will be very clear and we move on. So thank you for making time with me today, and I hope to see you in my study room the next time I come. And I strongly encourage you once again to subscribe to my channel, so that anytime I upload a new video, you'll be notified to follow through. See you another day. Bye bye.